Thank you very much that you reached the 4th floor. Let me introduce myself. This is actually an experimental presentation. My colleagues asked me to tell a little bit about the life of developers and architects, and not just about the insides of the database. So my presentation is mostly about architecture and Postgres from the eyes of developer. My name is Nikolay Ryzhikov. I'm CTO of Health Samurai. We're working in medicine mostly. It's called... The system was installed in several hospitals in California. We are also developing telemedical systems. We also worked a little bit with St. Petersburg's government, and our main product is backend service for medicine with Postgres in its heart. I will tell you about a few problems and solutions that we found. But first I would like to learn a little bit more about you. Who is administrating databases and who is developing? Most people are developers. Good. Usually I make presentations on functional programming. We are in health IT, and I can tell you about the limits and our area of interest so you can understand our thinking style. First of all, we're not high-load application. Medical application is not a high-load application. It's just limited with the number of doctors in the hospital. We're not big data. Even if you collect all the cards, medical cards from Moscow, they will be able to fit in one database, so we're not big data. Our problem is the complexity of the subject area, and we're fighting with it. And it's interesting how Postgres can help us to solve this difficulty. What does it mean, a complex domain? Who has more than 1,000 tables in their database? Who has less than 1,000? Who has less than 500? Who has less than 100? So approximately 100 tables. But sometimes it can be thousands of tables. And I'm working on international medical standards. There are about 300 entities, and if I convert them, it's more than 2,000 tables. And this is actually a problem. These are the entities in the standard which we can use to describe the data of a patient, and it has many inserts. And if in the second column something starts with a capital letter, it means that it's a complex did and something is inserted inside. And even e-commerce doesn't face such a problem that often. Who faced such a problem? Just 2 people. Okay. So which instruments do we have to fight this problem? Who read the book of Eric Evans, Database-Driven Design? If you are into architecture of complex business systems, you should read this book, for sure, I recommend it. And there is such thing as DDD aggregate. For example, there is an entity of a patient, and other data and data elements like patient's contacts, languages he speaks. These are mostly the data which belongs to this entity. And if you take all these tables and collapse them to these aggregates, there will be less and the cognitive load will decrease. And what's good is that this approach, DDD aggregate, works very well with JSON. This is also an explanation why document databases became so popular at some point, because this is a very good match. From technical perspective, if we look at JSON, we can look at it as denormalization on steroids. Who used it in their practice? We've been arguing for a long time, and joins are actually expensive. If you have a big entity spread along the several tables, we can use JSONB as denormalization on steroids. Even if you will not use what I will tell you later, it will help you a lot. So this is a problem of number of entities, and then we have more complex problems such as variability within a class of entities. A classical example is a product warehouse in the store, for example. We think it's some products that we sell, but on the other hand, television sets are quite different from washing machines, and they have their own attributes. And this is the heritage diagram on the slide. And how can you solve this issue? I would like to talk to you. There is not so many of you. Please raise your hands. Who uses the tables inheritance? Who uses type columns and many optional columns? And then they define the entity based on the type, maybe even for different classes. And again, one of the solutions can be JSONB. This is a spread table which can store different information, different keys, and to tackle this variability even within one class. Then even more complex problem. Everything in our world is integrated, nothing is isolated. Who has more than one integration? Who has an isolated system? Who has 10 integrations? So I hope you understand what I'm talking about. What does it mean, integration? It means that the system is open, we talk to other systems, they are replaceable, and they change, and we need to design a system so it goes not very painful. There is extensive and intensive approach conceptually. Let's call it closed world, and open world. Closed world concept is very simple. If I don't know something, it means that it's not correct. And in most cases, we design a system in this way. And if some new field comes in or new entity, our system crashes with exception. And it's good if you have some monitoring, so alert will go to the developers and they will take measures. And the database is also a closed world. If something new comes in, it can crash. If we think as an open world, it means that if I don't know something, I analyze only what I know. There is a good approach for work with complex data. It's called semantic web. There is a certain scheme to describe the entities, and initially they're designed as open systems. Theoretically, it's a very well-developed concept. Internet of pages maybe will become an internet of senses. And technically, to realize such an open system, JSONB can be used, and maybe you will get this time advantage to understand what was sent to you. For us, it's very important as well, because we are trying to create a platform. It should be open. But what do we pay from technical point of view? When it was JSON line, we paid every time it parceled. Now we pay 20% for access. Also, we pay for space on the drive. It depends a lot on the profile of your data. If it's text paragraph, then maybe you will not pay much, but if the size of a key is comparable with the size of your data, then maybe you will pay 2 or 3 times more. But again, it should be measured, and there is experimental extension JSON, which inserts numbers instead of keys, and we heard that JSONBC is in development, and I hope that people from TG Pro created page-by-page compression, and JSON will be compressed very well, almost disappear. Hopefully sooner or later it will be part of Postgres, and then we will not have to pay that much. Next point, there is no statistics on JSON. They are working on that, but currently there is no statistics. And next problem, when we work with JSON, there is less concurrency, and if we are trying to update a page of this JSON, we need to lock it, and if this resource was distributed on several pages, then we could update only one page. So JSON will get a little bit bigger, but for us, the complexity of the subject area was much more painful than this small performance penalty we have to pay. There is also the thing that when we get open JSON, some scheme is meant. It's quite flexible. We don't have instruments, but we can write constraint to check all your documents and to create some sort of shape, for example. When we use JSON scheme, I've been asking for a long time to write extension for Postgres to run JSON scheme inside Postgres, but now we're compiling it in JSQUERY, which we'll talk about later. Also another example, RDF style scheme. In the database you have a table with columns, and each column has a certain type. And the scheme is related to attribute, and this attribute as a string is basically hung in the air, and it can have attributes from different schemes, and you determine the type of the entity, not just extensively putting a label that you are a user, for example, but if patient has password and login, then it's user, and at the same time this entity can be a doctor. So if you feel this pain, you can look at semantic. It could solve many problems in Postgres. I have a fantasy to try to compile triple store in JSON and Postgres. Also, for the schemes, it's very important that you should not let the scheme dominate over semantic. This is also quite interesting. In our case, all our tables look approximately like this. There is timestamp and there is resource, and all the tables are the same. We store the scheme described in attribute style, and then we generate JSON scheme and analyze it. You can try to compile JSON scheme. So let's assume that you put your data in JSONB. Now the question is how to search. Can you see the code? So the simplest case, if something is stored on the first level, you have arrow out of the box operator and you can reach the elements inside JSON, and the penalty for this will be very low. It's almost like access to the column. Can you see better this way? Okay, I will highlight the code. If we put JSON in there, we need to update it somehow. We can get it and save it, for example. So, for example, we can create a simple functional indexes. Who used them in Postgres? Basically, they're the same as ordinary indexes, but the speed of search in JSON will be almost equal as search in the columns. If we need to change it, we have standard operators like deduction, for example. Also, this is a piece of a real code which updates JSON string. We need to hack it a little bit, but it's possible. All such expressions we generate based on our OPP, and sometimes we can write it manually. If standard operations are not enough for you, you can use PLV8 language, which works very well with JSON. For executive jobs, it works much faster than SQL, because V8, a lot of resources were invested in V8. So V8 engine is quite fast, and if you need to perform certain transformations with JSON, just install V8 and you will be able to manipulate JSON. I recommend it. Also, our document can have more complex structure, and sometimes we might need to perform sophisticated search, maybe by email or by phone number, and using standard operators it can be done, for example using JSON array, but it will not be efficient, and this is why we need JSQUERY extension. This is a data type where a certain language is used. It's quite rich. There are many keys, different conditions are used. Very good language. Many queries can be written using this language. Also, there is operator for indexes, the hash, the paths, apply filters on the path, and as there is no statistics, you can send hint what to index and what not to index. And one index covers many queries for the same document. You don't need to index each field separately, so many queries can be covered with one index. So check it out. This language can return either true or false. So it can be used as a scheme for JSON. Just install a certain constraint on the table. And if you changed the document scheme and you want to check that everything is fine in your database, or to choose the documents, you can write select using this scheme. Please try it yourself. JSQUERY limitations. JSQUERY operates in the same area as JSON, so you can insert only string, number, and boolean. There are no dates, for example, or something more complex, no operators, which exist in Postgres. So not all the queries can be written on JSQUERY. Further mentioned that commit was created to extract a part of the document using JSQUERY, but I couldn't find it. So we wrote a simple extension, it's called json-knife. Instead of developing syntax, we can use JSON. It doesn't have any complex filters, it's just a path, and then it matches and goes into all the branches and returns you the certain number of variables. For example, timestamps, numerics, aggregators. When you have several dates, you are interested in the maximum. This is related to the medical standard. If you are interested, please check it out. And Postgres is working actively on realization of SQL JSON standard. I didn't like it from the first sight, but I think that many databases will support it soon. A little bit about nice things. Even if you don't store your data in JSON, you can reply to JSON, as we have a function for construction of JSON objects and aggregation of JSON objects like JSONB, AGG. We can write many queries and to return big JSON document. There is also root to JSON, which converts string from the table into JSON. And then you can use JSONB AGG, and you will get a massive of JSONs. And in such way, you can insert a lot of metrics in one query and send it to JSON. Also, there is a pivot called JSON object aggregate, where you can aggregate the keys. So instead of getting flat tables and choose them on the client, it can be done within the database. And also there is Facebook GraphQL API interface. We used the tools from Postgres to compile GraphQL queries into effective SQL queries. So in the end, using the queries, we can get JSON in the end. And this function compiles it quite effectively. If your data is stored in one database, you can avoid such problem. Well, next, JSON is not ideal. Of course, there is not many types, and Postgres has more useful types, and we discussed it, and I saw in the Oleg's roadmap To get a solution for this problem, we would like to see primitive types inside the JSON. Some superset of JSON. We're using tags, for example. We could show that this string is actually a timestamp, for example. This is not very hard to do, as JSONB contains Postgres types. Just we need to come up with a certain notation, and if parser doesn't understand it, it makes it a string object. And if it understands it, then it can make it a native object. I will tell you a little bit how we develop in general. We like functional programming. Functional relational programming. And there is an article out of the tar pit where our guys analyzed which problems they experienced during development, and they said that it's better to write in a functional style, and where they need state, they will get relational database and some elements of math. If we look at our classical web application, everything it does, it gets certain data, text requests, and then it's transformed into database query or insert, and this data is inserted in the database, and the query results are received, transformed, and sent back. It can be done in functional style or in relational database. This is why I'm against all kinds of norms. And we asked ourselves, where is the most complex business logic in this area? And SQL is actually relational programming, more declarational paradigm than functional programming. It has its problems, which are not at the root of the relational approach. It's just such a realization. We see SQL sheets, but it doesn't mean that it's correct. We have some abstractions, we can create view queries, but this is not very efficient. And for example, right now it doesn't exist in the database, and we build this abstraction in our EPP. And we represent SQL not trying to use strings, because machine is talking to machine, and it's better for them to talk with some structure of data like JSON, and this data structure can be composed and inserted inside, and you cannot do this way with strings. They will have to be assembled in a certain way. We just write the data structure. The syntaxes can be a bit scary, but this data structure, when we build query, it returns data structure. We compile SQL, we send it, and then we get data back. Inside the code, we represent it as SQL and abstraction, and the amount of code reduced significantly in comparison with Java, for example. And you see the core meaning of the code. And all our efforts to attach something and then use SQL anyway is not efficient. The next interesting thing about Postgres, which is what everybody is interested in, it's some reactivity in the application. Everybody wants immediate updates if something happened. We're looking into that direction as well, and Postgres has something like called logical replication. Logical replication is a stream of all changes in the database which you can listen to, and then you can do whatever you want with it. You can install some decoder, for example JSON decoder, and from existing connector you can open logical connection where Postgres will write all its changes. And then we can write to Kafka, and many subscribers are in Kafka who can decide what to do. They can send to web a new update via socket, or maybe to store it somewhere. So check out logical replication as well. So you can use source of true, you can write in it and get some feedback which you can analyze or execute in UI for the user. Who works with JVM? Not so many. But we discussed a few times that JDBC is outdated and it should retire. There are many useless things in it. And we wrote some code for Postgres adapter. If you are interested, connect. We should get rid of JDBC. We need full functional Postgres. I mentioned a few ideas. To create prepared statements, to avoid management in user space. That's it. Thank you very much. And questions, please. Thank you to the speaker. Good evening. My name is Roman. I argued with my colleague about JSONB usage. I said that JSONB will take more time from the CPU in comparison with one-column search, and he said no, it will be the same. And now you're saying that it's 20%. You can actually measure it. Yes, I measured, and I measured 20%. Just insert in the same table. Yes, we created 500,000 entries in the table. We searched either way, and yes, it's almost similar, but something else may be slower. The problem is that it will take a lot of space, as I/O affects query speed very significantly. So JSONB will take more memory. It depends on the data shape, but in general it takes more space. It takes a little bit more space than JSON string. But if you have the same problematic points as us, you should look at JSONB, as from architectural point of view it can simplify many things. And what do you think about Hibernate, for example? I try not to think about it. I actually thought about it a lot, and then I left OP and I understood that it's too abstract, and these are just some random entities which we do not need. With Hibernate we can, for example, send custom query with some section from your data. Why do we need to write an entity for this? But SQL is very flexible. I can take all kinds of data. Why do I need to map? Just for convenience of processing. But what is the convenience? If you are interested, we can discuss it further, but I'm against ORM and I am for SQL. My name is Denis. I would like to ask you, in your medical database, you are using JSON, and accordingly, do you have a task of aggregation of data? As I understand, JSON works a bit worse with aggregation of data. Well, simple basic queries can be sent. If we're talking about serious analytics, we didn't do it in Postgres, so I don't know. Simple analytic queries work very fine, very fast. But you've said that medical system contains hundreds of tables. It means that even if there will be dozens of tables, they will be interconnected in a very complex way, and it should be inserted in an analytical system. What is your solution for that? Well, quite often you don't need all the data. You just need a certain cut of data. Yes, it's if you know which reports you need, but if you need some new reports which you didn't have before, you will need to redevelop the whole application. But when we use JSONB, we still have SQL, we can join them, and many queries can be built on JSONB, and some of them will be actually faster, because we will not have unnecessary joins. But we should review a certain case, because we never encountered such a problem. My name is Victor. I have a question, a little bit provocative. During the first part of your presentation, you told us about horrors of JSON, that certain data types are missing. But why you are not using XML, which exists for a long time, but they have all of that? You can store everything in the database. But why are you using JSON? It's just a trend? Or for me, XML is for Martians. For us, it's very difficult to... I agree that it's quite similar. That's exactly my question. Why JSONB? To be honest, I hate XML, and if even any startups never choose XML. It's not a trend, it's just actually specific things. JSON can be mapped quite logical for your structures. We can discuss it further, but if you saw code on React, for example, where you insert tags, you will see that something is wrong with XML. XML scheme, I participate in standard, and I'm trying to kill XML. Many people wrote for XML, but we're trying to destroy it. But it's very convenient and useful thing. It's quite flexible, yes, and they are similar. And you don't need validation. right away. All the schemes are described, but you will not be able to write normal scheme. There will be... Okay, let's just discuss it later, after the presentation. Any other questions?
My name is Mikhail. I have a number of questions. Number one, no reference to asynchronous DBS driver. It would be quite interesting to see it. And what about the beginning of transaction and if it is synchronous? It's not quite clear for me. You mean the beginning and the end of a transaction? You mean the way it manages a transaction? Yes. How is code written? Where does it limit the beginning and the end of a transaction? If it is conducted simultaneously, and where is the session in that case? How are specific queries linked to the threads? Well, there is a more mature driver, JDBC, on a scale. And here, the simultaneous nature means that for every connection you will need a thread. And Postgres exchanges messages with its client, and these messages can be processed using one thread. So I can give you some links if you want. And the thing that I wrote here is a proof of concept that is to be improved. I took native and implemented the protocol of Postgres message. Regarding transactions, well, anyway, your transactions go on in connection. You send them to SQL and conduct rollback or commit. And when you send this message, your thread is engaged is something useful. It is not waiting for the Postgres response. So you can use it. And you removed whole mapping. And aren't you afraid of losing time safety? I have a presentation on the last day of the conference. I am against standard programming. Thank you. Thank you. Do you have other questions? We have time for them. My point is that types are not well linked with information. I have the following question. You showed very interesting constructions regarding JSQL. Is it related to variables binders? Move on. Yes, here. The previous one. Yes. This is update. No, could you go back? JSQL. Yes, JSQL. When we look for something, can we add some bind variables into this query? For example, a question mark. And instead of this question mark, client will write some number, some date or text. Well, if you take it from some language, you can parameterize that. In JSQL, there is a line that you will have to link, but you will be able to provide parameters. This will be about the transfer of a variable to client. How will it look? Well, you do not have a literal. In JSQL, there is a data type with a line literal, and you will have to bind it. So, well, SQL injection can be removed here, but you will have to bind them. Thank you. Someone in the first row wanted to ask a question. Regarding JSQL, you'd better address further and Alexander. I work with GraphQL actively, and I would like to specify, was it your academic interest, or do you have a client who works with it? It is under development now. We have a backend for medical service, and in the format of standards, in Swagger format, we provide this, and there are lots of similar problems. We have internal protocol that is very similar to GraphQL, and we plan supporting GraphQL in Postgres. We have this information in open source. There are several implementations on Postgres. Thank you. Do you have other questions? Hello, my name is Semyon. How do you cover your functions, your functional development by tests? Do you test them? Yes, we do. Well, I will try to answer your question. I like writing functional tests. So you write a functional test for REST API. Sometimes in a library you can write unit test or generative test. We like testing, we test everything. That's great. In the very beginning you told us about a medical standard, and you described a model, yes, a complex domain model. Is it a medical standard? It's an international, well, you said it's a Swagger. No, it's a fire. Like fire in English. F-H-I-R. It's an international standard under the aegis of Charles Server. It's quite a famous organization engaged in standardization of information exchange in medicine. It's a new standard, and you implement a solution for this standard. Yes, we take part in developing this standard. I attend working groups and roundtables, and we create a commercial solution. This standard describes the server and data warehouse. Thank you for information. Do you have other questions? There was an example where you wrote SQL and you mentioned that Scala will take much more time. That I think it's possible to create such a translator on Scala that will rewrite everything for SQL. Maybe you will even be able to add time safety. I'm sure that there is a DSL on Scala, and it is quite possible to write SQL there. Well, I meant that you can use SQL as a tool for expressing business logic. And if abstraction SQL is not sufficient, you can do it through your code. You can express part of this logic in one system and part of another, and after that you can compose them. You can reuse projections and joins, and it is not a part of SQL. You can create a more composable language to create SQL pieces. Yes, I see you. My name is Vladimir. I have a question regarding implementation. In the beginning you said that you have a lot of tables of 2000 type, and you showed a scheme of these tables. They have 3 fields: ID, timestamp, and JSONB. So why instead of 2,000 tables, can't you use one table where either inside JSON or in a separate field the type will be specified? This flexibility is appearing, and we can do it, but still we have a standard. We have grouped with entities already, and inside each entity, inside each type of resource, there is its own classification. The schemes are similar, and you can place several types into one place, you can do partitioning, you can write unions, and there are many advantages here because at the level of the basis Java is similar. Even if you do not use JSON, some queries can be composed through JSON. And regarding 2,000 tables, well, in the beginning we tried to do it in a relational way and we generated it into a relational model. We had 2,000 tables and making 30 joins, well, it just died when there were million entries, so it's not an option for us. Hello, my name is Stepan. Regarding Fire, on GitHub you have a project Firebase, and the last commit took place 10 months ago. Will it develop? Well, if you want to develop it, we can transfer it to you. But will you develop it? Well, it is used in many places. No one wants to pay for it. We rewrote everything for proprietary code. Part of it is available. Extensions are open source, and the drive itself is similar to the one made in Firebase, but it's a new rewrite with review of everything that has been done. It is written inside Postgres, and unfortunately, it's quite difficult to support it. One more question regarding Fire. Have you written any UI for the standard? UI for the standard? Yes, some graphical work with the resources. Well, there are several. Our product gives UI. There are open ones. There is a clean Fire. If you're interested in Fire, I can give you a link. Thank you. One more question. I would like to ask the following question. If we look at this JSON that describes almost all the objects, it has timestamp. Do you use some breakdowns for the base that are valid for a specific level of time spent? For example, you have a patient's card and you have a unified ID of a patient, you have a timestamp, and there are some fields like name, surname, patronymic, and when you insert a new entry, do you renew the previous one or do you add a new entry with a new timestamp? And all transactions, and you can use versions depending on the client. Well, first of all, the standard contains history and PI. All updates are recorded, and we have a twin table where this story is written. So if you renew something or you delete something, it still stays in the story, but we stole a lot of ideas from Postgres. We have a notion of logical transaction. It's not a time spent, but it's another meter for putting tags for the purpose of versioning this PI to get only new parts on updates. So we just took ideas from Postgres and transferred them to a higher level. Thank you. So we have our last question. One more question. It is not related to JSMA. In your structure, how do you arrange hierarchical data, for example, KB10? And why MKB10, International Classifier of Diseases? Why 10? How do you arrange it? Well, there is CD9 and CD10, different versions. And in America, they have International classifier 9 in Russia, it's classifier 10. There are lots of dictionaries in medicine, and we created one big table where every terminological concept has a system code so display, and after that you can do anything. You can load other parameters, and the hierarchy can be done through connections. So we can simulate some graph things, graph queries, but all dictionaries were united in one table. You can partition it, and it is a table where you can find various reference books, lawyering for laboratory tests, and all the terms that are used in medicine. So we did not create a separate hierarchical entity for reference books. Well, it's quite easy to create a tree through materialized past. So if you need a tree, you can use materialized past. Thank you. So, we ran out of time. If you want, you can speak to our presenter. Thank you, Nikolay, for your interesting presentation.